Chapter 8, Day 2, we are going to review greatest common factors, finding it, and factoring polynomials using the greatest common factor. So let's review some terminology. Factoring is the process of finding factors, like finding the greatest common factor. And a factor itself is a number that goes into a larger number, and it's a number or term multiplied with another number to get a product. So the greatest common factor is the largest number and or letter or variable that goes into two numbers, or what we call terms. When we have something that's relatively prime, that means that is when the GCF is 1, like the number 1, and or there are no common letters or variables. Okay, so if we have something like, this is what we did yesterday. If we have something like x squared plus 2x, and we want to find the greatest common factor, okay, we would take each one and list the terms and find the greatest common factor. So the greatest common factor of this example is x, because we would break the x into x times x, and we would break the 2x into 1 times 2 times x, and there is a single x that is in common, and that's why the GCF is x. So that's a factor. X is a factor of both x squared and 2x. So when we factor it, what we do is once we have that greatest common factor, remember, that it gets divided out from each term, which means we're left with x plus 2. So again, this x right here is a factor. And this x plus 2 right here is also a factor. And when we multiply them back together, so a factor times a factor is equal to that product. Okay, so that's kind of hopefully helps you remember what some of these things are. So let's try some together. So again, we're factoring using the GCF. So we need to find the greatest number in common and the greatest number of variables if that is the case. So for 2x and 8, okay, we have factors of 1 and 2. And for 8, we have factors of 1 and 8, 2, and 4. Okay, there is an x, a variable in this 2x, but not in the bottom. So our greatest common factor is the number 2. There are no common x's down below, so we cannot have a variable in our greatest common factor. So our GCF is equal to 2. So then we put that GCF on the outside of the parenthesis. What's left from each term goes inside after we divide by the greatest common factor, so this would give us x minus 4. And that expression, that binomial we had, is factored into 2 and the other factor of x minus 4. Let's try another one. Let's actually jump to number 3. Okay, I'm going to jump to number 3 here, and I am going to find the GCF of 5x squared and 7x. So my number part is 1 and 5, and then I have 2 x's in this top term. In the next term, this is also a prime number, so 1 and 7, and there is 1x. So what's in common is 1x and the number 1, But if we only had a 1, we would consider it relatively prime. But since we don't, our GCF is 1x, or just x. So that goes on the outside, and what goes inside is after we divide each of the terms by x. So 5x squared divided by x would give us 5x. Negative 7x divided by x gives us minus 7, and that is now factored. Remember, those two multiplied together, if we multiply those together, we should get the original binomial that we started with. Okay, let's look at number 2. Why don't you try that one on your own and then restart the video for explanation. So when you're trying to find the greatest common factor of 16, you would have 1 and 16, 2 and 8, and then 4. Okay, there are no letters. When you're looking at 12y, you have 1 and 12, 2 and 6, 3 and 4. Okay, and there is also a y. So now look at what's in common. There's a y here, but none up there. Okay, then my largest number that goes into each, that is in each list, is 4. So my GCF is simply 4. So 4 goes on the outside. What's left when you divide goes in the inside. So this would be 4 minus 3y. And of course, they get a little bit more complex when you have 2 or when you have 3 terms. Okay, so I'm going to have you try number 4 on your, well, actually I'll do number 5 with you, and then we'll have you backtrack and do number 4 on your own. Number 5 is maybe a little bit trickier, so I'll do that one first. It's just bigger numbers. So what I have here is I am looking for the greatest common factor of 22g squared, of 44g to the third, and 88g to the 6th. So the factors of 22 are 1 and 22. The factors of 44 are 1 and 44, and 2 and 22, and then 4 and 11. And these are things you can check on your calculator. Now, you also have some G's in here. I didn't write on the top one, there are 2 G's. In the middle, there are 3 G's. And in the last one, there are 6 G's. So, we'll come back to the G's. Let's do 88. We have 1 and 88, 2 and 44. 3 doesn't go in there. 4, 22, and then 8 and 11. So what is the largest number in common? Well, it happens to be 22. So also notice that there are 2 G's common here, so we can only circle up to 2 G's in both of the other ones. So this is where that smallest exponent power comes into play. When you have a common variable, it's the smallest exponent power that is your greatest common factor. For the number part, my greatest common factor was 22 and then g squared. So my GCF comes on the outside, 22g squared. What goes on the inside is after I divide by 22g squared. And don't just cancel that out, because that's not just 0, that is the number 1, and you need that placeholder. Okay, then we divide the second term, the middle term, by 22g squared, and that gives us minus 2g. And we divide 88g to the 6th by 22g squared, and that gives us 4g to the 4th. And again, you can always check these by going ahead and multiplying using the distributive property. Remember, you can multiply these together, and that should give you your double check to see if you got what you started. All right, you try number 4, and then you can restart the video for the explanation and the work. Okay, so for these, I need to find the greatest common factor of 3a to the third, 6a squared, and 9a. Notice that's my lowest exponent power, so I know that that's going to be the largest variable I can take out for my GCF is going to be something a to the first. Okay, let's do the number part. So we have 1 times 3, and then we have 3a's if you want to list them out, but we already kind of took care of that. You have 1 times 6 and 2 times 3, and you have 2a's. And finally, you have 1 times 9 and 3 times 3, and you have 1a. So your greatest common factor in the number piece is the number 3. And you have, again, 1a in each. So my greatest common factor is 3a. That goes on the outside. And what's left is when I divide by 3a, I would get a squared. When I divide the middle term by 3a, I would get minus 2a. And when I divide the last term by 3a, I get simply 3. All right, so hopefully that helps you review those pieces. So here are a few more. And again, they get a little bit more complicated. So what gets a little bit more complicated is just there are more letters involved on these. So I'll do 2 of them with you, and then you can do the other 2 on your own and check the notes for information. Okay, so to factor these, I need to find the greatest common factor between 10x to the 4th and 2x squared y. So what I'm going to do here is first take care of the numbers. So the factors of 10 are 1 and 10 and 2 and 5. Again, I'm closing my gap and nothing else goes in there. Then I also have 4 x's. For 2, I have the numbers just 1 and 2. Then I have 2 x's and a y. So now let's see what's in common. Okay, the largest number in common is 2. And I have 1 x to circle in each. There is not a common y, so I will not have any y's. But notice, there are 2 x's in each. And so notice, again, x is going to be to the second power. So my GCF for this is 2x squared. When I factor that out, 2x squared, what I'm left with when I'm done, again, I'm dividing each term by the greatest common factor, which would give me 5x squared minus y. And that's your answer. Okay, I'll have you try number 2 independently and check back to the notes. I'll go ahead and do number 3, and then again you can do number 4 independently and check back to the notes. So question number 3. Again, we need to find the greatest common factor of 4y to the third and 16y to the fourth and 8xy squared. So I like to list the numbers first, 1 and 4 and 2 times 2. And then I have 3 y's. Okay, for 16 I have 1 and 16, 2 and 8, and 4 times 4. And then I have 4 y's. So 1, 2, 3, 4. And last but not least, I have 1 and 8, 2 and 4, and I have an x, and I have 2 y's. And again, like before, okay, there is only an x here. There's not any x's on the other ones. So I won't be able to circle any x's, but I can look for the lowest y's that I have, and notice that equals 2 y's that I can circle in each term. So part of my GCF will be y squared. The number part of my GCF is the largest number that can be circled in each list, and so that would be the number 4. So my greatest common factor is 4y squared. That comes out. And what's left is when I divide by 4y squared, which would give me y, divide the middle term by 4y squared, which would give me 4y squared. And then divide the last term by 4y squared, which gives me 8x. No, I divide by 4, that would give me 2x. Sorry, I forgot to divide the number part. So that would give me 2x. And that's your answer. This is the end of the video portion of this, but again, try some of those other problems and check the notes for day 2.